Mm. Yesterday we studied the uh, artist absorption and putrefaction and the degradation of the protein. And the protein you can say lysis and degraded and produces the amino acid. So today we begin to study the uh, metabolisms about the amino acid in vivo. Uh, um, Especially for the degradation of the amino acid. You can say amino acid you can see through the deamination and through the oxidations and the metabolisms about the ammonia and last you can say thoroughly metabolism. Okay, you can see today and the first we begin to study the you can see the carbon skeletons, the amino acid you can see the which is the first question, the deamination. Uh, the amino acid, the first deamination. Uh, how to deamination? Several methods can be deamination. Uh, and here, my students remember the combination of the deamination is the main pathway for the deamination in vivo. In body, you can see. What is the deamination? You can see the process by which amino acid is separated from the alpha amino acid to form the corresponding alpha ketone acid. You can see the down. You can see list the amino acid as the formula. You can see the molecule. You can see, for example, here R1. You can see the side chain. It is R1. You can see and last produces the alpha ketone acid. This process we see the first you can see it is deamination. How to deamination? How to do deamination? The first kind of the transamination. The amino group can be moved their location from one amino acid transported to the another molecular and produced another kind of the molecular. Here you see transamination means you can see one kind of the amino acid and added the another alpha ketone acid. Transaminase catalyze you can see produce the another kind of the alpha ketone acid and produce the another alpha amino acid. You can see this formula. You can see the first you can see is the R1. The side chain is R1. This amino acid you can see from the group to the another alpha ketone acid and produce another kind of the amino acid. But here you pay attention to the R1. This produced another kind of the alpha ketone acid. So this is the transamination. I just at the beginning, I emphasize all of you in vivo, in body, the combination of the deamination is the main pathway of the deamination in vivo. First, We studied the first kind of the deamination. Maybe some students maybe interested, you can say only here you can say the amide group from one molecule you can say transported to another molecule. And never deletion, but my students pay attention to. For this formula, you see is the amino acid thoroughly deamination. But another molecule you can see act as the acceptor and received the amide group. Uh, Here you can see most of the amino acids may be removed the alpha amide group through the transamination, except the lysines, prunings, hydroxyproline. Uh, these three kind of the amino acid can't be deamination through this method. Here you can see through this kind of the method, uh, transamination. And here my patent in our body, the GPT and the GOT in normal tissue, especially in the liver, you can see these enzymes is very higher, is very higher. Uh, Here the G means is glutamate, the P is pyruvate, T transaminase. Uh, and another one you can say G is glutamate. O you can say oxidose acetate. T transaminase. Uh, from this table, you see is these two enzymes in the liver, in the kidney is very higher. But here you pay attention to in the steering is very low. For the normal person like this, if the person maybe affected the virus, if maybe the livers maybe running working, at that times, for example, tumors, it is on. At that times, you can see steroids transaminase activity immediately increase. So all the times you can see can be used as one of the index for the diagnosis and prognosis of the disease. So maybe for this, our students maybe come to the China at that times go to the hospital at that times you can see extract your blood and separated the steering and detected the transaminase activity. Uh, and doctor maybe tell you your body is very healthy. Uh, these two exams also is very normal. Uh, Another one you can say all of the transaminase have the same cofactor, coenzyme, and the action the mechanisms like this. Uh, First, the amino acid you can see transported the amide group to the phosphopyridoxine. Pyridoxine, vitamin B, right? And accept the amide group and produce the phosphopyridoxamine. Uh, and furthermore, from the cofactor, and removed the amine choose another alpha ketone glutarate and produce the glutamate. Uh, this may be in the future ask you transaminase the cofactor. What kind of the cofactor? phosphopyridoxine. Must remember that this from here pyridoxine phosphate, and here you can see produce the pyridoxine phosphate, glutarate, and produce the glutamate. Uh, for the transaminase, the rules of the transamination is not only an important way for the amino acid deamination, but also important pathway to synthesize the glutamate. In this way, no free amino produced. Uh, so yesterday we studied the putrefaction. I emphasize for you for hours for all of Earth, the ammonia is very toxic, especially for the liver system. So at that times you can see this process from the first kind of the amino acid transported the amino group to the another molecule, and from beginning to the last, no ammonia produced. So it's very safety. There you can see glutamic acid dehydrogenase kinase makes the deamination of the amino acid. Dehydrogenase kinase and sometimes glutamate, you can see, can be produced the alpha ketone glutarate. This step you can see can be here once and pay attention to. This enzymes is very useful and thoroughly deamination. But here, this enzyme's main focus located in the liver, brain, and the kidney. And the coenzymes, it is NAD or NADP is okay. But the GDP and ATP is the inhibitor. Because produced the alpha ketone glutarate can be entered into the group cycle and oxidated thoroughly and released energy. So GDP and ATP is the last products, terminated products. And the GDP and ATP act as the activator. So you can see these enzymes. Maybe some students maybe think, why choose this kind of amino acid? Because these enzymes have the highest efficiency. So can be all kind of the amino acid you can see through the transamination and produce the glutamate. Glutamate dehydrogenase kinase and thoroughly deamination. So from the beginning, I explained for you the combination deamination is the main pathway for the amino acid deamination. So here you see combined together and forms the combined deamination. So the combination of the two kinds of the deamination, which cause the amino acid to take off the alpha amino acid to produce the alpha ketone acid. This is the combinated deamination. You can see here. Combine the two kinds of the enzymes and make the amino acid deamination. You can see this method is not only the main ways of the amino acid deamination, and the main ways to synthesize low essential amino acid. This located in the liver, brain, and the kidney, especially for the glutamate dehydrogenase. This in the livers and the brain and the kidney with the higher activity. Uh, Glutamate releases the amino group as the ammonia in the liver. Maybe students think, wow, here mainly released the ammonia. Other location, what trouble? What kind of the trouble? For example, the brain deamination produces the ammonia and the times make the nervous system toxicity. Toxicity. Another thing you can say in liver, the glutamate is transported from the cytosol transported into the mitochondria, where deamination, oxidative deamination, catalyzed by the glutamate dehydrogenase. Uh, in the mitochondria, is the used to synthesize the urine. So don't worry, no problem. The combined action of the aminotransferase and the glutamate dehydrogenase is referred to as the transdeamination. Uh, at that times, you can see two kind of the methods. Here you can see the amino group is removed by the purine nucleotide cycle. Uh, Further, um, certainly, this kind of the method deamination is very little and only take place in the liver and the muscle. Uh, in the heart, you can see the transaminase 1 and produced the glutamate, and the transaminase 2 produced the aspartate. And furthermore, you can see the adenosine synthesis catalyze and one molecule's inosinic acid but with one molecule's aspartate. You can see produced adenosine. This molecule you can see the adenosine lactase catalyze and you can see produced furic acid and produced the at the same times you can say produced the AMP. AMP furthermore you can say hydrolysis produce the you can say anti-lanic deaminase produced catalyze and produce the ammonia. Uh, this you can see here. In fact, we studied the four kind of the methods you can see deamination. The first you can see the amines catalyze can be make the amino acid deamination. Second, you can see the glutamate dehydrogenase catalyze can be thoroughly make the amino acid deamination. Third, it is the main pathway make the amino acid deamination. The combined action. Oh, oh, mm. And furthermore, you can see the amino acid deamination and lift the carbon cyclating. This kind of the cyclating is very useful, and at times one can be oxidated thoroughly. Another way can be used too synthesize other kind of the molecule. For example, you can see amino acid, you can see completely oxidized and provided energy. At another pathway, you can see produced the amino acid. Furthermore, you can see the alpha ketone skeleton transported another side and used to synthesize the amino acid and used to synthesize the protein itself. And last, you can see can be converted into produce the sugar and the lipid compounds, especially for the ketone bodies. So here in our e-book list all kinds of the amino acid you can see can be used to synthesize the sugars, can be used to produce the glucose. Here, all of this you can see all kinds of the amino acid you can see divided the essential amino acid and low essential amino acid. Essential amino acid you can see this kind of amino acid in our body can't synthesize by ourselves. Only come from the food. So here you can see for the amino acid you can see can be only synthesize the ketone bodies. Some this you can see the this speak four kind of the amino acid you can see only synthesize glucose and sometimes can be synthesize the ketone bodies. So totally you can see can be, and another one you can see here listed the red color. You can see all of the 14 kind of the amino acid you can see can be synthesized the glucose. So here glucogenic amino acid you can see adenine, adenines, asparaginins, aspartate, and cysteines, glutamate, glutamines, glycine, purine, serine, and histidines, methionines, threonines, valine, and at the same time can be produced the glucose and the ketone body. You can say tyrosine and isoleucine, the phenylalanines, tryptophan, and all can be synthesized the ketone bodies, leucines and lysine. All of this you can see the total oxidated thoroughly. This temperature you can see the through the reaction the carbon can be entered into can be entered into. For example, the adenines, the cysteine, sterines, threonine, tryptophan through the deamination and left the carboskeleton can be produced as the pyruvate. Pyruvate can be entered into the mitochondria and oxidated thoroughly. And another one you can say isoleucine and leucine transfer can be produced acetylcholine. Maybe some people think here you can see the tryptophan not only produce the pyruvate and at the same time produce the acetylcholine. Tryptophan deamination and left the carboskeleton hydrolysis produced the pyruvate can be produced acetylcholine. So here you can see this PPT list all kinds of the amino acid how to oxidated thoroughly. You can see here the adenines, hesitating, running it so on. You can see here. So here you can see list all kinds of the amino acid you can see can be photo-oxidated thoroughly. Uh, this part you can see, in fact, I teach all of you and teach all of you. In our book, you can see list 4 kinds of the deamination methods. And last, this PPT is, and normally you can see, enjoyed this PPT is very useful. All kinds of amino acid, you can see how to oxidate thoroughly. Through the deamination and hydrolysis that produce the what kind of the carboskeleton and oxidated thoroughly. This chapter we finished. Okay, rest 10 minutes. We continue study the next chapter.
Cierto, man.
上次就是碰到那个啥，不碰到车道，就是碰到机杯后边的那个。原先在这个桌子上放着，我没地方放，我就放在那边。 今天什么？ Okay, my students, pay attention to. And now I have the emergency scenes I must to deal with. So today the class we stopped here, and for the metabolisms about the ammonia, tomorrow we continue to study. Okay.
Okay, 老师。
Okay. Today class is over.